So this the sensor that we used 3 years ago. Like right now, we are not using this one. The idea to using this one is to determine how much force that actually generate during the scoliosis surgery, so that when we design our force sensor, we can have a broad range, like the idea of how much load we need. So at that time, we're using a string gauge type sensor. So when it have applying the moment, we can measure the force and loading. And also at that time, it's already using the wireless, but we are not using the 402 band wireless. So after the surgery, we need to remove that sensor and then put the real screw back into the body, so that it's not living inside the body. But in the future, we are going to leave the whole sensor inside the body. So there's some of the idea when we measuring the force and moment. So the force is around 100, without the legend, and the green is about 100 Newton, and here is the moment. So we've been working on the force sensor for about 3 years now. We finished the prototype already, and we are doing the calibration right now and checking inside our brand, inside the lab. And this one is our sensor. The idea is to have a strip, and we have two sensor pack on each strip, and each one have 4 individual sensors. So from this, we can recalculate or model the 3-dimensional forces applied to the on the screw head or the hook head. So here's the idea is to putting these strips on the head of the screw or the hook, and one side will be our power, and the other side will be our wireless transceiver. So in terms of the wireless design, we are working on our first prototype, and so the idea is to making around 9 millimeter. This one is 9 millimeter by 18 millimeter, and we still thinking it's too big to attach to the screw, the head. So the idea is we will make it into a flexible PCB so that we can bend it, and then the whole thing will be within 1 centimeter by 1 centimeter, with the thickness is about 4 millimeter. So there's a lot of challenges building these devices: the power consumption, the size, the data rate, operating range, the reliability, the packaging. So these are all the challenges when you're building your implantable devices. And our next step is to do more laboratory tests on both the wireless and the force sensor, and we are working on the packaging as well to make sure it's biocompatible. And the next step is to perform the clinical trials. So thank you very much.
Thanks, Edmond. So we have a couple minutes if anybody has any questions. Yes.
Is this only going to be implantable in people that have had this current cultural, wasn't it, surgery?
Right now it is, but as I said, there's a lot of other applications. And also I have another sensor that is using for the hip implant.
Okay, for this scoliosis, this monitoring this force, what is that for long term?
The long term is we can understand the loading, and we can, when we build up our database, we know how much force we require to treat a certain type of scoliosis, and then we can build a computer model. So for helping the surgeon as well as the residents, one of the problem is for the residents, they need to have a lot of training before they can actually doing the surgery. But these days, the waiting list is about 9 months for scoliosis. So we need more surgeons, but this resident is not ready. So we want to have some education program for them so that they have some real like simulation and idea to help them to get these faster to go into the operating.
And be good for the research.
We'll take one more question up at the back.
Other than size for your wireless platforms, are there any other concerns you have in terms of materials that are going into the device, for example?
Yes, like right now when we design the platform, we also select a specific material, and also like when we design the wireless like on the wireless, we look at titanium, but at the same time, titanium is not good at transmission, like for the antenna side. So there's a lot of research on that as well. But I know once we design the device, we can also package it into called the bone cement. Like we did that before. So basically package the whole device into a bone cement module so that it will be biocompatible.